Hello, here's the key for the 9.1 to 9.3 quiz. All right, question number one. So we have this diagram right up here. The diagram represents the gas phase reaction of NO2 to form N2O4. And based on this diagram, which of the following best predicts and explains the sign of the entropy change for the reaction? So delta S. So delta S is the measure of the disorder of a system. So if we have fewer particles of gas, we're going to have less disorder. So we should expect a negative delta S. So that eliminates C and D. And now we just have to have the correct explanation to go with it. So it's going to be letter B. It's negative because the number of molecules in the gas phase decrease as the reaction proceeds. So letter B. Question 2, which of the following particle diagrams represents a process during which the entropy of the system increases? So again, we're looking for more disorder. So in A, this is the correct answer. It looks like we're going from a solid to a gas. So we have the particles have more freedom to move about. They have more energy in the gas phase. So the gas phase has the highest amount of disorder, the most entropy. So it's going to be letter A. In letter B, we're going just the opposite direction. You're going from a gas to a solid, so you're decreasing the disorder. And letters C and D are pretty much the same situation. They're all representing a gas, but we're going to fewer particles of gas, so it's going to be less disorder. So the only correct answer is A. Question 3. So we have two samples, and it looks like in sample 1, we're going from a solid substance into what looks like, now the particles look like they're not as ordered, so this is probably a liquid, and these particles are in the gas phase. In sample 2, you're going from that same solid, but now all the particles are in the gas phase. They're all relatively far apart, and they're taking up the entire container. All right, so the question is, which of the following best compares the relative magnitude of delta S and gives the sign for the entropy change undergone by each sample and why? So we should expect to see an increase in entropy, so they should both be positive. But in sample number 2, you should expect a larger change in the entropy because it's all being converted into a gas. So we have sample 2 is greater than delta S for sample 1 because the change in spatial distribution of the molecules was greater for sample 2 than for sample 1. So if everything is turning, all the particles are turning into a gas, the particles have more space to move around and there will be more disorder. So letter C. Question 4, which of the following equations represents a reaction for which the standard entropy change is positive? So we're looking for a reaction that will produce more disorder. So reaction in letter A, we have fewer moles of gas, so that's going to decrease the disorder, so that's not it. In letter B, we're going from gas to a liquid, so again, we're decreasing the disorder, so it's not B. In letter C, we're going from a solid to a solid and a gas. So when we go from a solid to the gas phase, if we're producing more gas, it's going to be a positive change for delta S, so that's going to be letter C. In letter D, you're going the opposite direction. You're going from a gas and a solid to just a solid, so we're decreasing the amount of disorder. So letter C is our correct answer. Okay, now we have the oxidation of PCl3, which is this reaction right here. Based on this information, we want to find the approximate delta S for this reaction. So this is the Hess's law calculation for the overall delta S for a reaction. It's going to be the products, the sum of the products minus the sum of the reactants. So we have to get an absolute value for our delta S. So products minus reactants, and we have to factor in the coefficients. So it's going to be 2 of the POCl3. So it's going to be 2 times 330, so that's 660. And then we're going to subtract 2 of the PCl3, so that's going to be 620. And then we subtract 1 for this oxygen, so we subtract another 210. And that brings us to negative 170 joules per mole Kelvin, so letter B. Okay, so for question number 6, we have the oxidation of iron solid is represented by the chemical equation above. Which of the following correctly explains whether or not the reaction is thermodynamically favorable? All right, so this is referring to delta G. We want delta G to be negative to be thermodynamically favorable. So this is using the equation delta G equals delta H minus T delta S. So we're given delta H, and we can see that it's negative right here. As far as it doesn't give us a delta S, but we can determine, because we're going from a solid and a gas to just a solid, that delta S is also going to be negative. We're losing entropy. The change in entropy is going to be negative because it's going to become more ordered, so delta S is negative. So when delta H and delta S are negative, that means the reaction will be thermodynamically favorable at low temperatures. So the negative T delta S term is minimized. So it looks like it's going to be letter A. There are more particles, including particles in the gas phase, in the reactants than the products. So that gives us a delta S of less than 0. Because delta H is large and negative, the reaction will be thermodynamically favorable at low temperatures. So letter A. Question number 7. When solid ammonium chloride is added to water at 25 degrees Celsius, it dissolves and the temperature of the solution decreases. Which of the following is true for the value of delta H and delta S? All right, so start with delta H. So we can see that the temperature of the solution decreases. That means that energy is being absorbed by the solvation process. So the temperature of the surroundings is going to decrease, so it's going to be endothermic. That means delta H is going to be a positive value. So that means that we can still have A, B, and C. That eliminates D and E. As far as delta S goes, we can look at the process that's taking place. We're taking a solid, ionic solid, and it's dissolving in water, so it's breaking apart into ions. So delta S is going to increase because it's becoming more disordered. So we have delta H is positive, and we also have delta S is positive, so it's going to be letter A. Okay, question number 8. Which of the following reactions is not thermodynamically favored at low temperatures, but becomes favored as the temperature increases? So this is referring to the equation delta G equals delta H minus T delta S. So when we have delta H and delta S both being positive values, it becomes thermodynamically favorable as the temperature gets higher, because we want to maximize the negative T delta S term to make the overall delta G negative. So the only one that has a positive delta H and a positive delta S is going to be letter B. So letter B is the answer right there. All right, and that's all for that quiz. Have a good day.